Hello, builders, and welcome back. We're in the home stretch now, heading towards the last half of our second day here. I'm going to be hosting the sessions for this point of the rest of the day, and we're going to kick things off with a presentation by Andrew Psaltis from VMware. He's going to be talking about simplified package creation in Bazel with rules PKG and PKG file groups. Take it away, Andrew.
All right, thank you for the kind introduction, George. As I am Andrew Psaltis, I work for VMware, and let's talk a little bit about a good friend, rules package and package file groups. During this talk, I will be assuming a overall basic knowledge of Bazel concepts, things like labels, attributes, etc. I'll explain other ones briefly as they're encountered for those who may not understand. So, very briefly, rules package is a rule set for creating packages in Bazel. There are 4 primary rules in it currently for creating tars, zips, debs, and RPMs. They're all nicely autonomous and very easy to identify. Each one of these is very good at creating archives, but they each have a different way of expressing how they structure their contents. So let's give a brief rundown of these. So first up, we have package tar. Package tar has a very advanced set of tools for manipulating package contents. Here we have strip prefix and packager, which control directories leading up to files. Modes, owners, and owner names control various properties of the files themselves, mostly permissions ownership. I believe there's even a groups one I left out here. There's also depths, which allows you to expand to other tars into this one you're creating. Symlinks for creating symbolic links, and remap paths for doing powerful path substitution. So this is pretty comprehensive. There's actually a few more that I missed, otherwise I would have run out of vertical space in the slide. But to contrast this, here's package zip. Package zip has far fewer features, despite the fact that it can contain largely the same set of information. So here we only have the ability to control the prefixes leading up to the files in the package. And of course, modification times. I believe package tar has a similar feature. And then moving on to package deb. Here, package deb is unique. Package deb here has a single data attribute that accepts, that it provides a tar file that consists of the package contents. For the core of a Debian package is a tar archive, so you would create a tar archive and pass it into data here, taking advantage of all of the powerful controls that package tar has. So next, and perhaps even more interesting, is package RPM. Package RPM builds an RPM using the RPM package using the RPM build tool. To do this, it uses a spec file. So a spec file usually represents full instructions for building a package. In this case, it is a template that you can use to, that Bazel tools in this package will expand to allow for easy access to the files you actually want to install. These are all specified through the data attribute. So this is the main motivator for this talk is we deal a lot with RPMs and a lot of other packages, but RPMs are by far the most complicated ones that I have encountered so far. So all of this leads to some questions that we had when we originally encountered this. It's so how do you rearrange paths consistently across rule sets? Each of these rule sets have a different way of controlling how you set up package contents. Some are more powerful than others. Some have powerful than others. Some don't need it. But it would be nice if there was a consistent way to specify things. I, for example, might want the remap paths control to make zip archives. How do you combine archives of different types? For example, I might want to combine a zip file, extract a zip file into an RPM. How do I easily do that in a package? Also, how do you reuse these packaging inputs? You would imagine a very similar looking zip archives and tar archives. You don't want to necessarily have to say the same stuff. Let's say the same stuff to create the package and repeat yourself. So there which should be a way to reduce the amount of times you need to repeat yourself. So the rest of this talk will go into some of our implementation to actually a solution that solves some of these questions and leaves open possibilities for answering the rest of them. So we'll go into a little more background, including a little more history, but along with followed by our description of our initial implementation of a fix, of a solution, followed by how it's evolved to where it is today, and then some planned features that should resolve most of the issues that we've encountered as we've built this out. So a brief story time. The legacy system that we at VMware have had to work with, obviously my product, had a generic packaging capability. You would just call some functions and they would allow you to generically map targets to installation locations. This was somewhat important because we had to deal with installing things for both Windows and Linux, and I didn't want to have to always have to deal with all the nitty-gritty of how each of their packaging engine works. You just say, I want file A, install to path B, and then it would do the thing and create the proper action in the installer. Another feature that we had was the capability of creating like a table representing packaging actions. We found this to be very concise way of specifying, okay, I want to install some file to some locations. Like simple things can be represented by just like a simple row with a table, rather than a very wide table, but a table nonetheless. So, as we moved along, we found that we really needed to take advantage of what Bazel had to offer for properties of performance and reproducibility. So when we were starting to look into our own packaging with Bazel, we found that we really missed these features. So we were looking and doing a little research into this and had an opportunity and to start on implementation during an internal hackathon. And while we were doing research for this, we encountered this ticket from Tony Aito, pretty much summarizing our exact feelings on this matter. We need something that allows us to go and take advantage of just generically specify how package contents are installed while involving the actual package builder as little as possible. So when we took a look at this, our immediate reaction was, we need it, I want it, I must have it. So we implemented a large chunk of it as a part of the hackathon. And then after a few iterations and conversations with Tony, we eventually got this, what we have following, into the experimental subdirectory of rules package. So this right here is the package file group rule. It effectively annotates the sources, provided sources with metadata that will be consumed by a packaging rule, like package RPM. So adders in this case is things like Unix permissions. Section is controlling certain package-specific attributes. Prefix controls where paths might end up, and renames also allows you to rename binaries from binaries created by Bazel to what you actually want them to be in the file, rather than installed. Some other features here is a strip prefix for using paths based on for preserving or deleting paths that are currently inside relative to your build files, and then excludes for excluding files for when you have multiple files in a single target. We found use for virtually all of these features in our packages internally. So next up, other entities you might often find in packages, things like directories and symbolic links. So we have a package makers rule, which provides the capability of creating a directory inside of a package with specific attributes. And package make links for doing the similar with symbolic links. Links in this case are a target to source map. So to cap all of this off, we've also created a package file group aware RPM builder. This rule will consume the values in data, the related things produced by the related packaging rules, and then build out an RPM spec file. this RPM spec file is similar to what the previous RPM builder made, except this time all of the installation commands that you would normally have to do manually are now created for you. So this is all. So once that is done, the builder will then invoke RPM build on it, and then get you the precise RPM you would want to have. We found this process to be much simpler than creating a spec file ourselves. We tried this once or twice and found the process to be error prone, not necessarily due to RPM's fault, but it can be a little cumbersome at times. Remaining attributes here are mostly related to RPM metadata in the RPM, things like releases, versions, things like that. Package deb also has similar attributes. So how does this all work? We take advantage of Bazel's provider system in order to annotate the files with actual useful information, with actual packaging information. So each of these rules emits a set provider, which are then consumed by the packaging rule. In this case, for example, package RPM, that will go and instruct it to create the necessary commands inside the RPM spec file for installation. Package files info contains information based on information for providing mappings from sources to destinations, from sources in the Bazel tree to destinations. Package dir info just specifies directory information, and package symlink info provides information on symbolic links. Each of these also contains various metadata for controlling the overall that can be applied to actually provide to install files, things like permissions, users, groups, etc. So we found overall this was effective. This is the only way we use to build RPMs internally. But as you can probably gather, it's quite verbose. Going back to our brief example at the beginning, you can see that each one of these these package file group declarations can get rather long. Just imagine you have many sources or many complex or many renames, and the list can just easily be 10 lines long. And then imagine you have like 20 or 30 of them. It takes up a massive amount of vertical space. And further, if you need to go and implement complex structures, like you need to have different files with different permissions in the same directory, you need to go and create a new package file group just for that. And that can be somewhat tedious. We found it relatively easy to navigate, but still it can be a bit. It can just be it can make things seem a lot more complicated than they really are, and we'd like to do something about that. So to help with this, we decided to take a step in a slightly different direction. So here's what we ended up with. So previously, there were only a concept of mapping rules and packaging rules. Mapping rules would create labels, map labels, or create entities inside your package, or provide the instructions for doing so. And then in the packaging rules would materialize the package, would follow those instructions and materialize the package for you. So to help allow for easier moving around of these of collections of mapping rules, we created a concept of a grouping rule. You may have you see here that package file group is now a grouping rule. Package files is now what package file group used to be. Package file group now collects a series of files, makedirs, and make links into a single entity, much like a file group would normally do. And then with these, you can go and provide additional transformations. Like, for example, a package file group can route files relative to a specific prefix. So you don't need to specify it in each and every single one of these mapping rules like you did previously. And then each packaging rule would now only accept the providers from package file rules. So to go back to our little provider diagram, now there have been plenty of changes here, but the biggest one of note is this is what is highlighted here in orange. The package file group is renamed to package files, and it's the same provider as it did previously, effectively. Adds it to a package, which is then, these rules are then passed to a package consumed by a package file group rule, which emits a package file group info provider, which is then consumed by the packaging rule, in this case, package RPM. So this is pretty much where we are today. Some progress in actual packaging rules, though. So package RPM is largely ready to go. It is available in rules package now. You can try it out. Package tar is currently being worked on and should be available soon. Package zip is going to be, since zip files are very similar to tar files, we have decided that we're just going to do tar first, and then zip will come very shortly after that. And since Debian packages are closely related to tar files, that will also be done after tar. I should note that Tony Ayuto has been taking a deep look into package tar and is actually the author of that change. And I'm gratefully indebted to him for his help and ideas in getting all of this moved forward. So, all that being said, we still have a ways to go. I haven't really mentioned all of the problems that we could have solved, but we wanted to solve. But so far, we haven't really done anything. If anything, we've made things go a little more complicated. So, somewhat of a brief aside. So, your standard open source build workflow looks something like this. You have a configuration stage, where you go and instruct the build. You say how you want the thing to be built. Typically, this is things like setting compiler flags, enabling or disabling features. Often this will go and detect the features you have available on your system and customize the build accordingly. The end result is that this often just generates your build system. Then you call something like make to actually do the building. And so it does all the heavy lifting, all the compilation, all the assembly, things like that. And then you often call make install to put the artifacts all in the location for use or staging for packaging. And one thing that caught me by surprise early on with Bazel is that it doesn't really have a make install. The make install in this case is like a target inside make, and since Bazel actions can't interact with anything outside of its output route, so our usual workaround for when we need something like make install is to produce a tar file that we would then do as a part of the build. And then when we're done with the build, we would have a script go and extract the tar file to the desired location. Effectively, then you get what make install does. This has a notable disadvantage in that you can't really control what a package. You can't. Package tar has a cost to it. You have to actually go and create an archive and then extract it. And since this is installation, it's preparing for installation or an output like this is at the end of your build, you will very easily notice any sort of difference any sort of time this takes. We've had very large installations or exports from packages take several tens of seconds. And this is something we would like to remove from our build. It's not parallelizable, so we can't really hide it. So our solution to this that we'll be working on soon is what we call package install. Package install is a rule that will accept package file groups and then create a script that installs files to the location specified within the package file groups. And then to actually do the installation, you would call Bazel run as specified down at the bottom of the slide. This will go and if you run this without having done anything before, it will go and build everything needed to package, as seen on the upper left, and then we'll go and run the installation. Also, a common feature in installers is this destdir convention, where you can specify a stage route relative to some directory. This is great for things like packaging. Now, that's one thing we've been thinking about. Here's another. So, as I mentioned before, package file groups, in this case, package files, can take up a lot of vertical space. This is just a series of just imagine you have an application with a lot of config files that need to go to slightly different locations. You have to come up with different names for each of them. And these all take up a bunch of vertical space. And the naming is very, very important and very useful for Bazel to have. You can go and it goes to easily identify targets that could break, and also serves as the keys for keys within the build system to ensure uniqueness. But however, for these things, you don't really build package files or package file groups yourself. You're usually not interested in the names of these. You just want to say like, hey, I want to install a file. I want to install some files. I want to create some directories. I want to create some symbolic links. So once we have looked into this, and actually we took a cue from our legacy builds and created this idea for this manifest style build specification. So this is a table consisting of a list of tuples. And each of these tuples contains a series. Each tuple contains a bunch of actions that would be used by the build. The top one in this case is saying copy the thing identified by label hello to user bin hello bin with an attribute of 755. This is if you were to do this in a package file group, this would be like 5 lines of vertical space. The name of this, when we go and add it to a package file group, would be then based on the index you'd find inside the manifest list, and also with default attributes to boot. Once you have all of this done, the output would be something similar to a package file group, and then you would go and be able to pass that to a packaging rule, just as you would if you had manually specified the package file. One little kink in this is that when you run Buildifier on something that has vertical alignment like this multiple white spaces in a tuple, it will go and squish them down to 1 white space. So any sort of visual alignment you had by putting spaces after the commas will be lost. My colleague, Andrew Psaltis actually mentioned a patch to Buildifier that will go and help alleviate this. And this will be very helpful for broader consumption of this idea. We haven't yet implemented it, but prototyping was proved to be effective. Now, some other things. Bazel has a lot of power of Bazel we're not yet exploiting. And so we've had some other ideas we're tossing around. So here's one of them. Bazel knows what files are supposed to be executable. Like if you create a binary target, CC binary, you know it needs to be always going to be executable when it's installed. So this mode then highlighted towards the bottom on the right could perhaps be inferred from the information in the providers emitted by CC binary or even other binary type rules. Next up is run files. So each run files are files that are associated with a build, associated with a binary that are not actually produced by the binary. They're often needed by it. So when you have sets of dependencies, you often want to install them alongside run files alongside the binary. Currently, there isn't a real effective way of doing that. The paths, among other things, the paths within Bazel and the paths within paths when installed can be radically different. We're not quite sure how to reconcile it yet, but it's something we're thinking about. Another thing is inferring information based on platform constraints. We can, for example, take each of the RPM and Debian packages are based on a target CPU architecture. This information could perhaps instead be inferred from the target platform as opposed to having to specify it manually, perhaps saving some space. Another thing for improving configurability is templating. Paths in package files and package file groups could perhaps be added, or be given templates so that users can customize your builds when they're customized installations when you actually build the program or build the package. So often, like for example, you'll find that libraries or some Linux distributions want to install documentation in user share doc, others want to do it in user doc. So this will help allow for this customizability that Bazel does not have natively. One last thing is the combination of archives. This is something that we have thought about, but we haven't quite implemented this. But the idea here is that this package expand rule will then provide an instruction to the packaging rule through package file group to actually go and install or extract the archive within the build process. That's pretty much all I have. Some closing thoughts. So a lot of what rules package has is driven by the needs of VMware and Google, because we're the ones primarily working on it. If you have needs you would like to see, we'd love to hear about them, especially ideas. There's a rules package mailing list, rules package discuss Google group. You can also create a ticket in our project. We also have a public monthly meeting where we discuss project planning and toss around ideas. The next instance of it is on Thursday, July 8th from 1:30 to 2:15 GMT. It's usually the first Monday of the month from 2 to 2:45. And also, lastly, VMware is hiring. We have several positions, perhaps with remote opportunities, that go in various build-related applications in the United States, Europe, and India. So feel free to message me or send me an email at the address specified there, and I'll be happy to chat with you about it. Thanks for your time. Now I can take questions.
Thanks a lot, Andrew. That was a great presentation. It's always good to see the rules package getting some love. I can remember using and abusing them from the very early days of Bazel's public release. So I'm going to jump into a couple questions. We have a whole bunch for you. Our highest ranked one and the earliest one is, for the new package RPM, does it still need RPM build in the exec host?
Yes, it does. It is still used to build the RPM package. I have talked to some folks, and I've heard in the past that it's very building. You trust it. Using an RPM package is not built by RPM build can have you missing all sorts of things, they found it to be the most reliable way of getting this across. You can now, one of the features that Tony actually added was the capability of supporting an RPM build toolchain. So if you happen to have a built copy of RPM build, you can reference it inside your Bazel build and use that to build RPMs. That is what we in fact do internally.
Tool chains for days. I love it. So next question is, are there plans to provide packaging for programming languages? The examples given here are NPM, PyPy, Ruby Gems, etc.
It's not it's not currently on our targets, but we actually haven't thought about that too much. I think it's something that we may want to delegate to the individual rule sets, but I honestly don't know. I don't have too much of an opinion on that yet. It's a great thought.
Yep. Okay, so let's see. Can I use the package file group to create a container image? In other words, are there plans to create a package Docker or something similar to that? Isn't so much. So one of the things that we haven't quite figured out is where rules package ends and other rules begin. So like what really belongs in the rules package core is not exactly clear. I could easily imagine package file groups used to assemble things like layers of containers, but it's not super in our plans yet, but it is like the other ones a good thought, and we hope that the package file group framework will enable this to be added. Awesome. So, Andrew, once again, thank you for your presentation and your committed work on the package tooling. Looking forward to updates on that.